Hi, class. We are going to take another set of notes today, sort of continuing the idea of taxonomy. So go ahead and open to your table of contents for me. The left side is going to be something called a dichotomous, which is a fun word, key notes. And that's going to be on page 55. And then, what did I call the output? Oh, the output is going to be called create your own on page 56. Okay, once you have that down, you can flip to page 55. We are, what I'm going to do is I've already have the notes written out. I'm just going to sort of reveal them and talk about them as we go. Dichotomous key. So this is how to use a dichotomous key at the top. Di means two. And the reason that's important is because this is a technique for determining the scientific name of an organism using two questions at a time. So let's say I go out into nature and I have a dichotomous key for types of maple trees, and I want to figure out the type of maple tree that I'm looking at and figure out its exact scientific name. So remember, through binomial nomenclature, we talked about last class, it's two names, genus and species. Well, a dichotomous key can help you figure out the exact scientific name. It's a little bit difficult for me to explain it using the scientific name. So I'm just going to use shapes to help you understand the concept, but I think you'll be able to figure out how you could use that to apply it to absolutely anything, really. So I'm going to give you an example dichotomous key. Let's start with 5 shapes. You know the names of these shapes, but let's pretend you don't know the names of these shapes. So I put a line up here for you to write the answer. I'm pretty sure you know the answer. So you're going to draw out the shapes. I've left the blank lines, but if you want, don't fill them in yet. Pretend you have no idea what these are called. And also pretend we're finding the scientific names of them. So let's pretend that the square had a scientific name and it was 2 binomial nomenclature. Let's say the genus was Cornerus and the species is Squarus. Pretending. We could, in theory, find out the scientific name of that organism. Obviously, these are not living, but same concept. All right. So, like I said, the questions come in 2s. So let's say I want to determine this one first. The questions are, and you can write this down, corners or no corners? Well, as you can see, it has corners. 1, 2, 3, 4 corners, in fact. So if it has corners, it wants you to go on to question number 2. Ignore no corners for now, because it doesn't apply to this question. So we're starting here, corners or no corners, corners, so we go to question 2. Question 2, 3 sides or more than, so plus 3 sides. Well, it has 1, 2, 3, 4 sides. So it's got more than 3 sides. So I'm going to go to 3. This one asks about the square. Are all sides equal length? Don't measure it. Let's pretend that they're equal. Or sides are not equal. So I'm going to pretend these are equal. They might not be perfect, but so the answer is yes. So this shape is a square. You see how I could be looking at a maple tree and it could ask me a series of questions and keep redirecting me to a new question until I get the answer I want. So it might say, are the leaves, like how are they positioned on the tree? Are they at the end of the Stems, are they coming off of the stems? It might be another question about the color or the shape of the leaf or the time of year that it has a certain flower. It might ask, whatever it does, it keeps asking questions until you get to the right thing. Okay, we've got square. Let's go to this one. Remember, you always look at one at a time. Never try to answer all of them at once. So if I go to this one, corners or no corners? It's corners. Go to 2. 3 sides or more than 3 sides? Oh, it has 3 sides. That's the triangle. This one, corners or no corners? No corners. That's the circle. This one, corners or no corners? Well, it kind of has a corner, right? So go to 2. 3 sides or more than 3 sides? I would say, or plus or minus 3 sides. So it's not 3. That's what I know. So I'm going to go to 3. Question 3. All sides are equal length? Nope. Sides are not equal length. Yep. So we're going to go to question 4. Has 4 corners? Nope. Does not have 4 corners. Yep. So that's the heart. And then last, let's look at this one. Corners, go to 2. More than 3 sides, go to 3. All sides are equal? No. So go to 4. Has 4 corners? Yes. So that's the diamond. Okay. So looking at this, it's a pretty basic one. I mean, real dichotomous keys that scientists use can be pages and pages of books just devoted to how to go out in nature and figure out the scientific names of different organisms. You can see how this could be really beneficial, because if you're doing a study on a certain type of evergreen tree and you need to verify that you're looking at the correct species, you could go through a dichotomous key to check that you have the right species. And also it ensures that you are understanding the different characteristics of that organism. Okay, series of 2 questions. Now I made this one up. It's not perfect, but I think you get the point. I've written it out as notes because I think it's really helpful to see it sort of drawn out. So if you need to take a moment to pause and write that down, I think that would be a good idea. There's a couple things I want to add, just tips about it and sort of definitions. So dichotomous keys, which is what this tool is, are used to determine the species of organisms you are examining. Usually the result will be written in binomial nomenclature, 2-name naming system. So remember, we just talked about that. Binomial nomenclature, that's the like Homo sapien, genus and species. 2 names, italicized, first one capital, second one lowercase. The genus and species. Here are the basic rules. It doesn't matter what kind of dichotomous key you're going to be looking at. We're going to give you more examples, so I hope you've been paying attention. Choose one organism to examine. So I wouldn't examine all of those shapes at once. I would just look at one and then answer the questions about that one. Repeat or read steps in order. So start with number 1 and go down. Go where it tells you to go. Choose between A and B. And then keep going until you determine the organism. That's it. That's how you use a dichotomous key. Not too shabby. You have really 2 options for the output. I know I said create your own dichotomous key. That is difficult, but it's kind of fun. So challenge, if you want to try to come up with a dichotomous key on your own, you can write out a couple animals or even make up alien species or whatever you want, and then create a series of questions that helps people get to the final answer. Make sure if you do that, that you include a key. So that's helpful. And then, I'm sorry, not and then, or you can do free choice output. So going back to these notes, pick one of the free choice outputs from your menu and do that. Do not do F, does not apply, but you can do any of the other ones. And that would be an option. don't forget, so we've moved from doing Flipgrid videos to show your work to doing pictures attached to your assignment. There have been major issues with that. People are not attaching images to their assignments. They're doing the work and they're not getting credit. That is a problem. Submit your picture. If you have trouble submitting it on Teams, email it to the teacher. It's better than nothing. Don't miss getting credit. That is very important. Okay. Anyways, take care. Bye.